Okay. So the next bit and the last topic, which is directly about sets. Cardinal numbers, or as I like to call it, counting with sets. So we're going to do a survey. Oh, where'd it go? Okay. So in our survey, we're going to ask people about which performers they like. Now, these are the results of the survey. Oh. Okay. 33 like Tim, 32 like Celine, 28 like Brittany, 11 like Tim and Celine, 15 like Tim and Brittany, 14 like Celine and Brittany, 5 like all the performers, and 7 like none of them. It doesn't matter to McGraw. Brittany, who knows which Brittany I'm talking about? It could be anyone. Okay. So here's the question. How many people are in the survey? How do you figure this out? Okay. Right. Why are we going to need a Venn diagram? Okay. So, for example, can we just add up 33 plus 32 plus 28 plus 11 plus 15? Da da da. No. Why not? Yeah. What are for example, which two groups might the same person appear in? Right. Does that make sense? So we need to figure this out so that we make sure that we count each person only once, because the way it is right now, clearly people are being counted twice, and in some cases 3 times. If someone likes Tim and Celine and Brittany, they get counted a bunch of times, and we don't want that. So, as a couple people suggested, a great way to sort this out is to make a Venn diagram. Okay, so the first thing we know is we're going to make a Venn diagram. The second thing is, how do we start labeling this Venn diagram? Yes, okay. So sure, we'll put TCB there. Let me actually write this down here. Okay. So we're going to make a Venn diagram. Okay. TCB. Now, what can I fill in immediately? 5 like all. And where does that go? That goes dead in the middle. And notice that that's great because there's no confusion about where that 5 goes. Right? And the 7 for none, we know exactly where that goes. Okay. So notice that the all and none, you do those first. You almost have to. Okay. So this was first. Okay. What can we fill in? Sorry? Okay. So 11 like Tim and Celine. And that's where can we fill this in, and what number do we fill it in with? Okay. Right. So that we're going to fill in. So Tim and Celine, that's the overlap. So what number do we fill it in, and what do we do? It's got to be a 6. Because 5 have already been counted. Does that make sense? Okay, great. So now what else can we fill in? 15 like Tim and Brittany. Right. Exactly. So we've already counted 5 of them, so now we have 10. And then what? Exactly. 5 have already been counted, so we can fill in a 9. So, so notice that these you have to do second. And then finally, we can fill in the other bits. So now what? Right. Right. Exactly. Right. So it should be 33 for Tim, but we've already got 10, 5, and 6. So that's 21, so you subtract that off, and what's left? 12. Oops. And then for Celine, 32 like Celine, but we've already got 6, 5, and 9. That's 20. So you knock off 20, and what's left is 12. And for Brittany, 28 like Brittany, but we've already got 10, 5, and 9. That's 24. What's left? 4. So notice the big difference between saying 28 like Brittany versus how many like Brittany only? 4. So that's a big difference between saying those two things. For example, last time some people were saying something along the lines of, well, there are 7 in the universe. No way. There are 7 in what? There are 7 in the universe only, and not T, C, and B. That's very different from saying there are 7 in the universe. Does that make sense? In fact, now that we've got everything filled in, we can actually go ahead and answer our question. How many people are in the survey? Now what do? Now you have the proper numbers to add up, because now everyone has been counted exactly once. And this works out to what? Let's see. Is it, let's see.
I got somewhere around 58 to
65. Don't forget the 7. So how many people are in the universe? 65. Because the universe is always everything. So, does that make sense? So, actually, I want to talk about notation for 1 second. One of the questions here is, what does 6 represent? It's the people who like Tim and Celine, but not Brittany. Now let's go backwards. How can we write that in set notation? Using T, C, and B. Just, yeah, for this one. How can we write this in set notation? T, sorry? Is it union C or intersect C? Yeah, intersect. And then what? Okay. So is that good? What happens when you do a union? Does that make sense? So in fact, we can actually finish this off by writing this entire thing in fancy set notation. We can say the number of T intersect C intersect B complement is 6. That's how we write that whole thing in fancy set notation. So notice that we can use intersect basically to list every single property of a particular person or a particular set. If we want to, so notice that T intersect B intersect, T intersect C intersect B complement says people who like Tim, people who like and people who like Celine, and people who don't like Brittany. So all 3 of those have to be true. As opposed to union where you just be collecting everyone all together. So all 3 of these are true about every single person. All right. So any questions about this problem? All right. So I'm going to have you guys do one on your own. It's a little bit easier. So work this out with the Venn diagram, and then answer the question. What does it look like? Yeah.
You draw a circle, and you put 5 in the middle, you go from like the whole height, you put an intersection. You put 0 on the outside because it makes nobody likes them. 0 behind it. And then because 5 intersect, you have to subtract it from people who are 3, which is 13, and you get 8. And then you spell 0 in this one.
Okay. So is that picture okay? Yes. Okay. Now what about this question? How many people like spring or summer? Uh-huh. And I'm sorry?
Yeah, spring and summer, but not the middle.
Why not the middle?
Because that's the ones who like both of them together.
Okay. Well, if you like both spring and summer, would you say that you like spring or summer?
That's spring and summer, not spring or summer.
But does it include? It includes that. It's okay. I'll tell you what. There's a. Actually, you bring up a good point. There's something that's called. Okay. So the question is, if you ask for or, spring or summer, does spring and summer satisfy that? So, actually, there's actually what's called an inclusionary or and an exclusionary or. So when we do a union, do we include that middle part? Yes. So that's the one that we use, and that's called an inclusionary or. So if you want to do, Terrell, what you're saying, we want to include the, if it's only exactly one but not both, that would be called an exclusionary or, and you have to make a special note of that. But notice that we're using the logic of the unions, where we say just include everything.
So when talking about only summer, how many people like only summer?
How many people like only summer? That would be 7. Is that your question? Oh.
Or
Yeah.
how many people have like spring or summer.
Right.
So when you're talking about a union, it's included in advertise, so if you're not talking about a union, it's either or, is what you said?
Oh yeah, was it either or is like one but not both or something like that? Yeah.
So it's between or
Right.
and. When you're talking about unions, you add them, and when you're talking
Yeah.
about
Actually, this has never come up before, so you raise a good point. So let's see. So if you want to talk about one or the other, but not both, that's called an exclusionary or, and we usually don't use that. And you'd have to make a special note if that's what you meant. In general, when we say or, we're saying an inclusionary or, so it's like a union, so it's include everything. So it's one, the other, or both. That's all fine.
What is the
Which part?
What
Well, in set notation, we're just talking about the union. So the union would be spring, summer, and then we take the union, and then we say how many, and how do we write how many in set notation? We just take n of that.
So if you gotta make exclusionary or, it's going to be on.
We're actually, you know what? We're actually gonna get to that later today. So I usually don't include that because it's usually skipped, but I'll include it for you. Because really, so far we've talked about intersection and union. When we start talking about things like and start talking about things like and or, that's actually the language of logic, which is what we're going to start today. But the ideas in set theory and the ideas of logic are actually connected, so I sort of slip between the two languages. And I'll show you the notation coming up.
Basically like
There's actually I've never seen the notation for it used in set theory. We just have intersect and union, and union just means everything together. Yeah. But this idea that you want to exclude the overlap, we don't have that in set. Well, we don't have a notation for that in set theory. We have a notation for it in logic, and we'll see it later. Okay. So now let's take a step back from this problem. How did we get the answer 20? Well, you could say one way we did this was we just made the Venn diagram and then made sure we counted each person exactly once. But there's another way to make sure that we count each person exactly once. Think about counting from the original numbers. 13 people like spring, 12 like summer. Minus the 5. Because in this case you've got two sets, but they overlap, so you've counted some people twice. How many people have you counted twice? 5. So that would be another way to approach this problem. Now how can we write this down as a formula? The number for
the number of SB plus number B plus summer minus number A, B, and B.
that's exactly it. So if you want to find the number of elements in the union, take the number of the first set plus the number of the second set, but there's an overlap. Those got counted twice, so you have to subtract that. So this is how we write that in fancy notation. So if I give you a problem like this, 24 people like red, 19 like blue, and 12 like both. How many like red or blue? With the formula.
43.
How did you get that?
Oh wait. 31. Yeah, 31. I forgot to minus the 12.
Right. (24) plus 19, but minus 12, which are the ones that were counted twice. And that gives you 31. And with the diagram as well, I'll sketch that in. What's the first thing that we fill in? The 12. Okay. And then what's left for the red? Red only, I should say. And what's left for the blue only? 7. And there you go. So alternately, you could just add those numbers up, and again, you get 31. Okay. You dig? Any questions?